When objects fall under the influence of the gravitational attraction of the Earth, a peculiar thing happens. The gravitational pull that the Earth has on an object is proportional to the mass of the object itself. That means that the more mass in the falling object, the stronger the gravitational pull. But at the same time that the pull is greater, the mass to be accelerated is larger. So that if you have an object with a large mass and the Earth's pull is larger, it accelerates as it falls downward. But if you have an object with a small mass, the gravitational pull is weaker, but the mass to be accelerated is less, and the acceleration, as it turns out, is exactly the same for the two objects. The masses cancel out. That means if you took masses, two objects of different mass, side by side, dropped them side by side, they would both accelerate downward with exactly the same acceleration and hit the ground at the same time. This canceling of the masses has an interesting consequence if you ever happen to go hunting monkeys out in the forest with a blowgun. I have here a monkey friend who's going to help me in this demonstration. He's protected with a flak jacket here of metal so that he won't be harmed in anything that we do. And in a moment we're going to put the monkey up high in a tree. Now in this particular tree, it's an electromagnet that holds him in place, and so we'll put him up there, held in place by the electromagnet. And then we're going to come over here to a blowgun, and we're going to fire at the monkey. But this blowgun has been outfitted in a certain way, such that there's a trigger right here at the end, and when the projectile, this little ball bearing, is fired through the blowgun and exits at this end, it triggers the release of the monkey, so that just as the bullet comes out, the monkey begins to fall from the tree. Now you'd think that it would take a great amount of skill in order to hit that monkey as he's falling down towards the ground, but in fact it's almost impossible to miss, and it comes about because of this canceling of the masses. You see, if you imagined a straight line drawn from the blowgun connecting to the monkey, and if you imagined that gravity were turned off and then fired the blowgun, the monkey at rest would remain at rest according to Newton's first law, because again, gravity's been turned off in our imagination. And the bullet exiting the gun will travel in uniform motion, straight line at constant speed, so that if it's aimed at the monkey, it'll hit the monkey. The monkey stays in place, the straight line connects them, and the monkey gets hit. But what happens if we allow the monkey to fall just as the bullet comes out from the gun? Well, in that first instant of time, just after the bullet is exited, the bullet will fall away from the straight line. Rather than following the straight line, it will follow a curved path, an accelerated motion because of gravity, and it will fall away from the straight line by a small amount. At the same time that the bullet is falling away from the straight line, the monkey high in the tree will fall away from its position by the same amount. And then as time goes on, the bullet will move further and further away from the straight line, just as the monkey moves further and further away from the straight line. And by the time they reach the same distance, or the bullet reaches the place where the monkey's falling, they should be the same distance below the straight line, and consequently they ought to collide. It ought to be almost impossible to miss under those circumstances. Well, we've seen what theoretically ought to happen. Now let's see what happens when we actually do the experiment. Monkey's now up in the tree, held in place. The first thing we have to do is we have to aim the blowgun very carefully. We have to aim exactly at the monkey. So we'll look up through the barrel until we have it aimed exactly right on the monkey. Then we'll put in the bullet, being careful not to trigger the release too soon. And then, carefully, without bumping it in any way, with lips of steel, we now